11. All right. So when it comes to adding probability, depending on how events are related, depends on how you add them. So, for example, when we were doing the mathematic, we had two different ways of doing the OR. We had just straight up adding, and then adding and then having to subtract out the and part or the intersection. Okay. And basically, the difference between the two was one was mutually exclusive, one was not. Okay, that was a big difference. So, this stopped moving. All right, there are times when I determine the probability of either event A or event B happening. And to do this, we have to be able to account for all the equally likely outcomes that fall into either one of the two events. And again, probably the easiest way to do ORs, if you can, is the Venn diagram. Okay, so let's look at exercise 1. Consider the spinner shown below, divided into 8 equally sized sectors. The spinner spun once. In the experiment, let A be the event of landing on an even number, and B be the event of landing on a prime number. And we're going to write it in the Venn diagram below. So before we do anything, we're going to state all of our sets. Okay? So first one, what's my sample space? What's in my sample space?
All the numbers.
All the numbers. So 1 through 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right. Set A, that's your even numbers. What numbers will be in this set? 2, 4, 6, 8. Okay, set B. So remind me, what's the prime number? So it's basically numbers that can only be divided by themselves in 1, and no, that does not include 1. So 1 is one of the few numbers that's not prime or composites. So it's going to be 2, 3, 5, and 7. Those are the only ones on that spinner that are prime. Technically 0.
All numbers.
Yeah. Well, 1 is the only one that's not considered prime or composite, yeah. And then we don't talk about the negatives because that's a whole difference. All right, so let's now put this stuff in the Venn diagrams. So if you look at the list of A and B, whenever we do a Venn diagram, we always start with the middle. So what number will go in the middle? 2. That's the one that repeats in both sets. So if I take 2 out of those 2 sets, what's left over in A? 4, 6, 8. So we took the 2 out and put it in the middle. It's still technically in the A circle. So the primes would be 3, 5, 7. Still including 2. It's still in that circle. And then what's the only one that got left out? 1. It's in the sample space, but not in any of our events. Because the legal definition of prime is that it's a number that can be divided by 1 in itself. Well, for the number 1 itself is 1, so it's kind of redundant. And there's a more mathematical reason, but it involves a lot of proofs and some stuff that'll go way over y'all's head. So. Yeah, you just gotta know the 1's not prime. No. unless you do some real advanced math.
Would that be like AP college?
That I didn't know that until I had to prove it when I was in advanced calculus my senior year of college. And by advanced calculus, I mean I was proving calculus.
So why are you a teacher?
I doubled majored in math. It was a 2-class difference. Might as well.
Is that AP math or something?
It'd be a rocket
science.
Yo,
Is that basically what it is then? Like all
Fisher, shut up.
but that's basically what it is.
Fisher, what does AP stand for?
Advanced place.
I'm trying to
So you're advanced placement.
Basically. Like AP
basically.
What does that mean? AP in high school is college.
It's like
What
a
is AP everything
a
college?
more
Big Murphy's trying to teach. Please. You love it when Goldie Fisher.
She's laughing.
So, if like just my life story real quick, my bachelor's degree is in mathematics, secondary education, and math. All right, I double majored, and the reason I did is because it was a 2-class difference. It'd be stupid not to. All right, because I can do pretty much anything with a math degree. So if I had somewhere down the lines, I wanted to.
I have a question. So, like, if you took all those maths and you're like really smart math, do you see things differently? Like, you don't talk about like, I like that. I'm like, something I do. Like, just thinking more imagine numbers. No, not like that.
Do you just mean like, do I just see things without having to think about it? Yes. So for example, when it comes to factoring, like some of the hard ones where you guys would have to do like the big X and everything, I can just look at it and tell what it is. So
Wait, why did you become like a professor?
I technically am one. Not here. I work at a community college too. Craven Community. I teach calculus on the side. Well, I haven't taught this year. I'm teaching during this summer. So. I mean, didn't you guys notice I was doing like a bunch of problems with it last week?
No, we don't.
No,
but you said like you had yourself last week.
I would say
She did.
I did. There was a lot of stuff going on last week,
No.
that's what I was doing last week.
but okay. So back to the lesson. You don't have half the skills you need for calculus yet. What I'm saying is that you at least need math 3 and pre-calc to do calculus. Right. Like you just don't have the knowledge yet to do it. Okay. I'm gonna start giving y'all the silent treatment if you don't shut up. Silent treatment it is. Can I talk now?
Yes.
Sorry.
Okay, so with probability, another way to say or and is union and intersection. Union is another fancy way of saying or. Intersection is a fancy way of saying and. They still mean the same thing. Or still means at least one. And still means both. Now, there is also some notation that you have to know. So with unions or ors, do you guys know how when I made you guys do interval notation, how if it like broke apart and made you draw that U in the middle? This is where it comes from. Okay? So this means union. It's like an uppercase U.
So you
Kind of. It's not quite a U, but that's what I associate it with.
So if it's not a U. Wait, so like, why does that mean or? Like, is that a dumb question? Like, why does union mean or?
Why does union mean or?
Yeah.
So I can explain this. Okay, so think about it this way. When you think about union, what do you think about? Nobody saying that together. Yeah, okay. But does that necessarily mean both at the same time, or does that just mean melding?
Like,
Oh, I'm so smart.
So it's not saying that we're only looking at the both parts. It's saying that we're looking at all of it. We're making a union of the two circles.
But I thought,
But like,
or,
whenever I think of
or
words,
is like,
one or the other.
it's one or the other.
So how does
it become a union?
Yeah, like,
I feel like they're like the opposite.
yeah, like union and or are kind of like two different meanings. Because like with or, I think of like two different things like separate, and then with like union, like together.
But it also depends on whether they're mutually exclusive or not. So in life, your version of it pertains to mutually exclusive events. But sometimes they don't. Alright? Because think about it this way. Let's do an example.
Like,
Like
maybe
$4
like
million hours. Oh, it's huge.
So let's say pets. Okay, like let's just go cats, dogs.
Yeah.
Okay. If I say who has a cat or a dog,
Oh yeah, it's like,
Oh,
okay, I get it, okay.
can you not both have a cat and a dog?
Yeah.
You can have one or the other, or you can have neither. Now, intersection is where they cross. Because think about it in terms of graphs. When I say the word point of intersection, I'm talking about where the two graphs
Intersect.
cross. Yeah. So intersection is where the two circles cross.
Does that mean there's gonna be like graphing on this or something?
yes, it's gonna be graphic on this.
Like if you call graphing making a Venn diagram, then yes, it's graphing on it.
Well, no, I mean like the why you would
You just say no.
Oh my god.
Yes.
You know it's that when you got
Only for our statistics that's really graphing is when we start doing like hotspots, grams, slides. What did you say? That's not one stuff. Histograms and everything. I don't know. I'm not going to see it.
I don't remember how to do it.
It looks like a bar graph that's all connected. Okay, so union means we're melding the two circles together. So if we're looking at the Venn diagram, everything that's between those two circles is within the union. Whereas the and would just be in the intersection of the two circles. Because that's where they intersect. That's why. So here's another example that you may understand, you may not. But let's say I had a domain of some function that was from negative infinity to 6, and then from 7 to infinity. I'm basically saying that I have graph from when x values are from negative infinity to 6, or I'll have a graph to 7 to infinity. So in other words, part of my graph's going to be here, part of my graph's going to be here.
So what would the middle be like if 6
There's a gap.
So would that just be two circles? Like
This would be one. But that's why we
So
use
how does it connect to what we're doing? I'm just trying to understand. The symbol that she uses, like the union. Okay.
So wait, is that like
So that
saying
these
that like
samples, that would be A and B.
So if I ask you to find where the graph was defined, this is the domain. I ask you to find where your graph is defined. Defined means there's physically graph there. So there will be a graph here, and there will be a graph there. All right. So they're saying you will find graph between x values of 3 and 4, or you will find graph between the x values of 5 and 6.
Oh, that makes sense.
That make more sense?
yes, but how would you put that into like a diagram? Would like 3 and 4 go?
What is your one?
Well, not this. This is more algebra.
I was just really asking.
So I was just trying to connect the algebra side of the union to the probability side of the union. They basically mean the exact same thing. You said know that. Okay. So I'm going to redraw that Venn diagram that we did up at the top real quick because we're going to use it for the next couple of questions. You don't have to because you guys can easily see it, but I'm just going to do it. So 2's in the middle, 4, 6, 8, 3, 5, 7, and 1. So that's sample space, B, A. All right. So if we are going to write out the sets, union just means combine. So if I look back up at my set lists, if I want the union of A and B, what would the new set be? So union means combine. It means meld together.
3, 4, 5, 6.
Right. So A or B would be equal to 2, 3, 4, 5, 6, 7, 8. We took basically all the numbers that was in this Venn diagram. Or if you look, all of those numbers are in these two set lists. We just don't have to repeat the two. Okay, so we brought them together. We melded them together. Does that kind of make more sense with union? What it is? Now, the intersection. So the intersection of A, B, which by the way, intersection is an upside down U. So just remember the two signs you know is a U and an upside down U. U obviously means union. It starts with a U. And then the other one will be intersection. So if you just remember which one's union, you got the other one. So what's the only number that overlaps? 2. And yes, you can have a set of one number. Now, N means the number of elements. So this means the number of elements in a set. So why is in the equation the number of A or B equal to the number of A plus the number of B? Generally, not always, not true. So here's my question. How many elements do we have currently in the union of A and B?
7.
There's 7 elements. So that is A or B. That's equal to 7. Yep. How many are in A?
4.
No. How many are truly in A?
4.
4. How many are in B? 4. Well, if I just put it like it is, they're saying that 7 should equal 4 plus 4. Is that true?
No.
Nope. So what's happening?
You're counting the overlap.
They're double counting the overlap. So it's not true because they counted the overlap twice. Overlap being the intersection. Intersection. It's just in parentheses.
Wait, so what
Not true. Sorry, when I write fast, my handwriting sucks.
When they say A or B, the union, that just means, is that the same thing as the sample space?
Not quite.
Not quite.
Not quite. Because
On the test or on the quiz, would we have it as a sample space?
Depends. Because remember, 1 is in the sample space, but it's not within the Venn diagram circles.
Oh yeah. So would that just be the Venn diagram circle?
Yep.
Oh, okay. That's
Or it's just what's in the circles.
so the uppercase U
Mm-hmm.
is like everything inside the circle,
Mhm.
and then the lowercase U
Mhm.
is everything that's in the middle that's shared.
Yep.
So would that have 3 circles? Would it be the one that connects all 3 of
All
them?
3.
Would it be the one that connects two of them together, or would it be all of them?
So it depends on what they're asking. Like, it depends on which events they're asking for. And we'll do more like that later on this week. But we're doing like the bare basic ones right now. So, in other words, to alleviate this issue of them counting the intersection twice, what do I have to do?
Also, how does it in parentheses A?
N means the number of elements in a set. If we go back up here, if you count how many elements are in A, there's 4. So in math, if you ever see an N, generally that means number. We mathematicians may make a lot of things complicated, but naming things, not so much. At least when we do shorthand things, we usually just put a singular letter, and usually that letter is usually what it starts with. So how do I alleviate the fact that they counted it twice?
By not counting it twice.
We have to do what?
You have to add every number in the circle.
But what if I didn't have that? You would subtract out the intersection. So what's the number of elements in the set of A and B? So how many numbers are in the intersection? 1. There's 1 number in that intersection. So I'm going to have to take 4 plus 4 and subtract 1. So is 4 plus 4 minus 1, 7? Yes. So in other words, N of A or B is going to be equal to N of A plus N of B minus N of A and B. So this is a pretty generalized formula for finding the number of things. I'll tell you what, that also transfers over to probability. So let's look at the next example. So now we're moving away a little bit from Venn diagrams, going to a two-way frequency table. So this is another method of which you may see information presented to you. Really?
That was not me. For the record, that was not me this time. We're not going.
So two-way frequency tables are a great example of we can combine events or sets with their union or overlap them as their intersection. So for this next problem, a small high school surveyed 52 of its seniors about their plans for if they graduate. They found the following data and wanted to analyze it based on gender. So if we picked a student at random, we can place them in the 4 categories. So M is going to be male, F is female, C is going to college, N is not going to college. And this right here is our frequency table. So they got the totals for each column, totals for each row. And if you look, those 2 totals will add up to 52. 30 plus 22, 52, 29 plus 23, 52. And then it's also nice because you can see some intersections in there as well. So the 4 in the middle, those are intersections. That's overlaps. So the first couple of ones, we're just finding the number that fits into certain events. So what's the number of seniors that will be male? 30. You just look at the total of the male column. How many female? 22. How many are going to college? 29. We want the total number of people that are going to college. How many are not going to college? 23. Now we're getting into some intersections. How many are both male and going to college? 16. You just look right where they intersect. How many are female and going to college? 13. Now, be careful about this. How many are female or they're going to college? I mean, they can still be female and go to college.
22, 38. 38. What? Where do you get 22?
Okay, so first off, what are the two first numbers that I need? What are the first two numbers that I need?
29 and 22.
I need 29 and 22. That's the N of F plus the N of C. So I got 22 plus 29. What am I missing? We got to subtract the N of F and C. Let's say intersection. So that'll be minus 13. So what's that equal to? 38. That's right, right? Okay. Okay. Shh. So now that we got generic numbers, let's talk probability. So what is the probability that a person picked at random will be female who is going to college? So first off, is this a union situation or a intersection situation? It's intersection because it says a female who is going to college. Keyword who is. So that is definitely an and statement. So we want the probability. So P of F and C. So what is that probability?
1/4.
Let's get the initial first, and then it does simplify down to 1/4. But what's the initial?
13.
52. Good. And that simplifies down to 1/4.
So you have a 25% chance.
Yep.
I think that.
Good job, Carson.
Now, what is the probability that a person picked at random would be female or someone going to college? So this is an or statement. It has the physical word or, so it's a union. So we want the probability of female or college.
So you would add the males going to college plus.
Well, don't we already have the number of
So it'll
females?
be 20.
19.
No. Well,
So-
it would be female.
Guys, we already got the number of females, of people going that are female or going to college. So can I just turn that into a probability? It'll be what? 38 out of 52. Which that simplifies down to 19. 19 what?
31st.
Not 31st.
31.
Oh my.
It's 26.
Say 38.
Divide by 2. I divide both the top and the bottom by 2. The 38 came from this question right here. Because we're finding female or going to college. What does that represent? That's why. We already found it. We just had to turn it into a probability. All right. Now, we're going to explain why the probability of female or going to college does not equal the probability of being female plus the probability of college. So we already know the probability of being female or going to college is, I'm just going to leave it in terms of 52. So 38 out of 52. What was the probability of being female? What's the probability of being female? 22 out of 52. It's 22. What's the probability of going to college? 29 out of 52. Now, if I add up these fractions as they are, what would that equal? It'll be 51. Now, even though that's not over 1, that means that 51 out of 52 people are either female or they're going to college. Which, that's a little high for all things considering.
Wait,
That either means we have a lot of females or we have a lot of people going to college.
that's
Or both. It Exactly. And we already found the true probability. They're not equal. But why? It's counting the intersection twice. So it's wrong because they count the intersection twice. So just like when we're doing the numbers, the way you calculate the general probability law for OR statements is you take the probability of A plus the probability of B, and then since they're going to count that intersection twice, you're going to subtract out one of those intersections. So the probability of A and B.
Couldn't we just add the males going to college plus the total females?
Can I get some money?
Yes. Technically, yeah, you could.
So could I do that on the test?
The problem with that is that that's only if you're given a frequency table. If you're not given a frequency table, that method won't work.
What if it? Wait, but couldn't it still work on a bit diagram?
Yes, but you're not always going to be given either one of those. Sometimes you're just going to have problems like if this is the probability, this is the probability of something else happening. What's the which we're about to do in just a second. You still need to know this rule. So this is something that you need to know.
Wait, is it just tomorrow?
No,
No.
we're not even halfway through. So biggest thing is that we got to make sure that we don't count an element twice. No.
Fisher mute.
Okay. Now, exercise 5. A standard 6-sided die is rolled once. The probability that a number was rolled was either an even or a multiple of 3. Well, they want us to find the probability that the number rolled was either an even or a multiple of 3, keyword or. They also want us to represent it as a Venn diagram. So let's just go ahead and make the Venn diagram. So here's my sample space. I got 2 circles, A and B. So remember, multiple of 3 means that it's a number that can be divided by 3. Now, think about the numbers on a 6-sided die. We always start with the intersection. What would go in the intersection? So in other words, it's going to be a number that's both even and a multiple of 3. 6. So what numbers are left on the 6-sided die besides 6 that are still even? 2 and 4. What about the numbers that are divisible by 3 besides 6? 3. What numbers were not included in our 1 and 5? So that stays in the sample set, but it's not part of our union. So remember, if you're just looking dead at a Venn diagram, what shows you the union? Not the middle, that's the intersection. What's in both the circles? So the probability of A or B happening is what? Well, it'll be 4 out of 6, which yes is in fact 2/3. There's four outcomes in the Venn diagram out of 6 total. That simplifies down to 2/3. Now, they also want us to verify that the probability addition rule is also true. So we're going to use the probability addition rule. So what's the probability of A happening? So remember, using probability of A or B is going to be equal to the probability of A plus the probability of B minus the probability of A and B. The rule we just came up with in the previous question?
So is that like the formula?
Nope, it's that. But I mean, if you don't remember the formula, it's really just the two add together and then you just subtract out the intersection. If you just remember that the intersection gets counted twice, you just subtract it out. Okay, so what's the probability of A happening? How many events were in A? No. 3. 3 outcomes can happen in A. So 3 out of 6. I'm going to leave it as in terms of 6. How many outcomes were in B? Nope. 2.
We just put the other one as even, right? That was an actual.
Uh-huh. So if I'm looking at just A, meaning if I ignore the B circle, we count all the numbers in there. So that's 2, 4, and 6. That's 3 numbers. If I'm looking at just B, that's 2 numbers. And then what's the probability of both happening?
5 out of 6.
No. 1 out of 6.
Oh.
There's only one number in the intersection. So 3 plus 2 is 5, minus 1 is 4, 6. That's exactly what we got. And that's the same thing as what we got here. We use the Venn diagram. Yes.
If we don't put B in parentheses A and B, so we like lose points.
When you're trying to find probabilities, yes, I expect you to put that notation. Now, I don't expect you to write out the entire rule every time, but I do expect this.
So why wouldn't it be 5 over 6? Why would it be minus 1 6?
Well, look at the 2 circles. How many numbers are in those 2 circles? 4.
Oh, I didn't see the 5.
That's why. Okay, last one. So this is an example of why you got to know the formula. So an insurance company typically tries to sell many different policies to the same customer. So you guys are a little young for this, but when you get to the age where you can start having a car or you have a phone or whatever, and your parents are like, nah, you can pay for it. A lot of times when you go to get insurance, you only go in to get a car insurance, and they're trying to get you to get renter's insurance. They're trying to get home warranty insurance on you. They're trying to get any kind of insurance they can.
They're trying to make money.
Well, yeah, they're trying to upsell you. So that's why a lot of times, because a lot of people fall for it, that's why they end up with multiple policies, but also because a lot of times if you bundle things, you save money. So like if you bundle, like, have you guys seen those Progressive commercials? Yeah. Mm-hmm. Well, they're actually right.
I thought they just made that up.
What?
I thought they just like.
Fisher, you
Well,
just stop talking.
okay. I thought it was just like they're saying.
No, it's an actual thing. If you buy both from your company, they typically you save money.
No, I thought it was they're saying.
Fisher, you should go.
And they were like advertising like Progressive.
That was like 19 having the same thing. We saw American flags. What?
I mean, they might. You never know.
Okay. So anyway, one such company, 50% or 56% of all customers have car insurance policies, 48% have home insurance policies, and 18 have both. So, keyword here, this 56% represents of all customers, meaning the intersections included. Same thing with the 48%. So, when they ask us in the next question to find the probability that she or he has at least one of the policies, that's definitely a union, keywords, at least one, that means or. Nope. So,
96%.
no. So, this is where I'm going to have to use the addition rule. So, all these percentages are probabilities. So, we don't even have to find them. So, how would I find it? Using the addition rule that I just came up with.
Add those two things and then subtract the 18%.
Add them together. So I'm going to add 56% plus 48%. And I'm going to subtract out the 18%. So yeah, 86% of their total customers have both. Not both, have at least one. Because remember, you can be an insurance company. You can have insurance from a company and not have car insurance or home insurance from them. Okay, I mean, for example, home insurance is not the same thing as renter's insurance. When I was in college, I didn't have The way my insurance was, my parents still pay for my car insurance, but I pay for my renter's insurance. So technically, I didn't have renter's insurance. So technically, I didn't have car insurance at the company I had renter's insurance with. And also, sometimes you just use different companies. So, like, I know some people that do USAA for some types of insurance, like home, and then I know that they use like Progressive for auto or something like that, just because USAA.
Hey. No, we do the same
All right, so last one. This one's kind of a review from yesterday. What's the probability that she or he has neither of the policies? How'd you get that?
Because it's like the opposite.
Mm-hmm. That's a compliment. So how do you?
You like get the other half of the 100%. You have to like find the opposite.
So you subtract it from 100. So you subtract 86% from 100, and that'll give you 14%. Okay, so your homework for tonight, you got a solid 30 minutes to work on it, is pages 13 and 14. While you guys are working on this, I'm going to come around and check off the past 2 homework assignments. So I'm checking off 3, 4, 6. I'm checking off 3, 4, 6. That was from Monday. And I'm going to check off the one from last night, which was 9 and 10. So I'm going to come around and do that while you guys are working on this. 3, 4, 6.